Okay, so today I'm going to talk on the error handling. So whenever we are writing code, while writing code, we as a software engineer expecting my program is work as per expected. Okay, but in the reality, whenever you are running your code in the production, you are getting some different scenario situation or applications are not behave as per expected. So those scenario are, you can say, consider as a error handling, right? So let us example, you have written a one function. Okay, function, you have written one function, and function have body 1 line, 2 line, 3 line, 4 line, 5 line. Okay, so expectation is that as a developer, the first this line executed, and then this line executed, then this line executed, then this line executed, and that's this line executed, and finally say, hey, what are the expected output you have to? This is the expectation our code should works. But what happened? Let's see, this line is done, but this line is not properly executed due to the some error, due to the some problem, due to some exception, yeah, unwanted input, not valid value. So journal by default, almost any programming language you can say, if the particular lines of code is not executed by the runtime environment, the program is closed and terminated. After that, you complete programs, complete functions, our program is going to shut. So this is the very bad situation. This is our responsibility as an engineer. We provide the meaningful information the customer or who is running the program why my applications are going to terminate it, right? So by default this application close. Why not give the proper message, hey, this line is not executed properly, and now you have to decide, you want to terminate the program or you want to continue the next line. This line should execute, this line should execute it. At least our application should run. That means you can say our application should behave with respect to the customer, not the default nature. So in those situations, our Python provide the error handling mechanism to handle the runtime errors and exception. So sometime you know what's error, sometime you know exception. Exception is the way I'm expecting my application work, but it not working. Right. So today we are going to discuss the possible way uh, which Python as a runtime environment offer for developer. So while writing code, we should aware any line of code, if our Python runtime environment going to execute, Python follows some syntax, semantic, some operating system concerns. If everything is as per expected, then it work. But might be sometime maybe user type incorrect value or the value you are reading from file is not as per expectation. So your application can go through exception or in error state. So Python provide very simplest way to handle these cases. Okay, so let us look. So let's first talk What kind of errors generally our applications can expect? First, the syntax error. That means, whenever you are writing the Python program, you are writing the setup statement, a line 1, line 2, line 3. But these lines statement, you follow the Python syntax. Syntax means how Python designed to understand your problem, your questions, your the business logic you're going to write. The first, the syntax error. That means if Python say I accept this is the print and this is the syntax, this is the curly brace, this is the close brace, and this is the there should be the some. So we have to follow this syntax. And second is the runtime environment. Runtime environment, that means whenever our Python is running inside the runtime environment, so sometime our operating system have some concerns, like you are going to dividing a particular number by 0. So what happens, we have a number 5 and you are going to divide by 0. There is a concern till now in the basic mathematics. You can say, hey, whenever you are going to dividing the 5 number by 0, it should be infinitive, right? But in the computer, there is no any concept of infinitives. So compile Python runtime environment say, hey, I cannot execute this statement. Where program going to terminate it. Are out of range. Maybe you have an array have only 3 element, element 1, element 2, element 3, and you want to, hey, say, hey, I want to element 5, I want to element 6, which is not possible. So this such scenario known as a runtime environment. Sometime our applications are throwing runtime environments, and also sometimes logical error. These occur. That means uh, you are written a particular functions. Okay, this is my particular function, and I pass x as my input, and we are returning out y as the output. So as an application tester or a customer passing the particular input, and the business logic you written, it works and responds the expected value. This is the correct. But sometime due to the some business concern or logical error or sequencing is not properly. So what happened, instead of you expecting y, you are expecting z output. So output of your function or application is not as per expectation. This is known as a logical error. These errors occur when your code does not produce the expected output due to some logical mistakes. Somewhere you have to apply plus, but you maybe apply minus. Somewhere you have to apply the AND operator, but you apply OR operator, or not follow the proper order of precedences, or any business logical error. So you can say high level error can be categorized syntactical error, runtime error, and the logical error. But Python support all other kind of error as well as. So what's the basic block? These are the basics of the Python error handling. Okay. So let's understand the code. Okay. So let us example, you have written my function. You have written my one function f1. Okay, f1 print f1. Okay, this is the f1. Let's we have a function 2, function 3. Okay, function 2, function 3. Okay, so let us you call f1, f2, f3. So this is f1, this is f2, this is f3. If you are running as per code, it's fine. Function 1 executed, function 2 executed, function 3 executed. Okay, so what happened? Let's say here you do some permutation. Let's say you say some number equal to maybe 2 plus 5. Okay, and just okay, here say comma z. Okay, so here maybe this is the one. Similarly here, maybe similarly here. Here. You run, it's working. Okay. So right, maybe here you are going to plus, maybe here you are going to minus, maybe here you are going to divide. Okay, something. So you are getting some expected out. But what happened here? Maybe you are getting something. Okay. And here say print uh, program done. Program app is completed. Okay. If you run, everything is fine. There is no problem. But what happen if say that's something you are getting something wrong or error. So notice our applications are closed and terminated with some kind of error or exception. That means by default the nature of our program is going to terminate it without properly completed. I want, maybe this is a problem, maybe a little I call this. Okay. So let's our function 1 completed. Function 2 failure, no problem. Let's write the sum as, hey, we cannot perform function 2, something error, something problem. And then function 3 must be executed. Because function 1 have not any problem. Function 2 does not have a problem. And this is the my close. So as of now, you notice my applications, this is my applications. My applications have a work like a function 1 completed, function 3 completed, function 2 completed, and one application is completed. Okay, this is the as per the out. But what happened? This is the code where the problem. But this is okay. This is okay. This is okay. So as of now, our applications are working as a default nature of the Python run environment, runtime environment. This means if anything unwanted happen, my application going to terminate it. Even after this, F2 is okay. This is okay, but still my application is not running. Okay. So whenever we run this code, you are getting the exception, right? So this is the way you can say this is the default nature of Python runtime environment. So this is the situation where we have to manage, handle. Hey, say no, don't worry. I don't want my applications are terminated. At least the other part. Maybe you think your applications. This is your applications. Consider this is your application, And in this application, this is the one module, this is another module, this is the another module, this is the another module here. Okay, this is another module here. If this is working fine, no problem. If this is the fail, might be this is working, this is working, this is working. That means ki my application have a couple of section, some section working fine, some section not working fine. The default behavior is that if not working, whole application going to terminate it, stopped. So this is the very not as per expectation. Expectation is that, hey, something component problem, don't worry, let them allow, hey, someone going to try to access this application, say, hey, this application is not accessible, or this is the some problem happened. But other part of the function or the other part of application, if there is no problem, it should work. So this is the importance of the error handling in the Python as a developer. So that you want to show at least the running part my application should run. Some the business logic, it's okay, hey, no, we cannot allow, maybe this is the dependency, these two are dependent to each other. If this is success, then you can perform this, then you can perform this. In this scenario, you can say, hey, this is the failure happened, we cannot execute this, we cannot execute this. Yeah, this is the right scenario. So depend upon your use case. Sometime you make the function dependency, module dependency. You can manage the hierarchy, but some other parts that are not under the one hierarchical or dependency that should run. So Python provide exception or error handling so that your application can behave as expected. Okay. So how to manage, how to handle this scenario? So for this scenario, Python come under the try except block used to catch the exception and handle the exception. So there are two situations. So whenever you are writing code, line 1, line 2, line 3, line 4, line 5, line 6. Okay. So this is your program. Okay. But you suspect this program can be problematic. Maybe line 1 problematic, line 2 problematic, line 3, line 4, line 2, I don't know. So you can consider this is a block of code can throw exception. So you have to write some sections of code. If something happen unwanted, what you want to test? Hey, go to the section here and you give the proper message. Hey customer, hey user, I got something problem. I want to give the proper error message, proper next action item, and after that your code other part still work. This is the basics of the catch and handle exception part. That means the code, the function which you expect can raise the exception, you can write under the this block. How to write block in the Python? Just how to Python come runtime environment. No, this is the code can generate exception. So this is a try block. And if anything's unwanted happen, your program is not going to terminate. They are going to the alternative option. Accept, and the error message, the warning message, the next instruction what you want, you can provide. Okay. And here you notice this is the exception type. So Python provide the list of inbuilt exception type like earth mathematical error, runtime error, or some business logics error, yeah, custom error. Okay, so these are the we're going to share the Python provide the huge all the list which the types of exception can be. But generally, normally, as a initial phase of the Python as a developer, we should know something like the divide by zero error. So this raise the when the program attempt to dividing any number with a zero. So this is the by default maybe value error. This error or any function or operation receive the argument has an incorrect value. Maybe type error. You are expecting integer or you are getting the some float or some different value. Maybe type error, index error and key error. Whenever you are working on the inside the your list or set here, in those scenario, the data are in the part of your index and you are trying to get the particular index outside of this your set or your list. So in this scenario, you can say a index error. Whenever you are working in the dictionary or map, uh, you generally working on a key and value concept, key concept and value key. What happened? The particular key not exists. So key maybe not found or setting the error. Okay. So I'll show all the type of exception, but these are the major types which you should aware initially. Okay. So let us try to write the code. So this is the basic syntax of the writing the code. This is the basic syntax to writing the code right now. So what is the basic syntax? You define your function. If your function take input and code, and just the business logic, I am going to dividing the number and printing the output. This is my code. Okay. So I know this operation divide can be through exception because this is the depend upon your input. If customer or any user pass the number that, and if this block exception occur, then the next exception, what the message you want to give, this message or this message, because the block of code can throw any number of exception, the different types of exception. So how to handle them? Okay, so let's code. So here situation our F3 functions need to properly handle. Okay, so here I know that this is the section of code is the problematic. If I'm not providing any kind of error handling here, okay, if you're running my code is the terminated. So let's first say, hey, I want to going put this under the try block, try block, okay, and accept, accept, okay, uh, divide by, okay, as any in div either, okay, and just print uh, errors, comma. So what we did, just say, hey, this block of code can be through exception. So I am going to make another try block. This is the try block. And if this is the happen, then I want to give this message, something error. And what the error message we receive. Okay. And if you run, then notice our F1 function is work fine. F3 have a problem, error division by 0, and again F2 is working fine and application is closing. So now our application is behave as per what we expected. Okay, now our application is not going to terminate due to the some unwanted outcome, unwanted flow of execution. Okay, so this is the very simplest way in the Python. Whatever the code you want to make exception handling, just put inside your try block. So this is the block of code. This is the block of code. Okay. This is the block of code. Okay. Put inside the try block, and anything's wanted happen, you provide the alternative error output. What the output you want. If you don't want to any output, don't want to any kind of error, you simply say, hey, this is the pass. I don't want any kind of body. But you want to give the custom message, custom error, you can write the body of whatever the output you want to show. So here, from this perspective, I know this is the divide exception. But this code is not just generate the division error. They can also throw maybe this is the input is incorrect, or this is the types error, or any kind of error. So this except block, this is the try block, and try block your code, written the code, and this can throw multiple kind of except. Maybe your except divide by zero exception, maybe error type exception, maybe value type exception. So different types you can handle, and you can, hey, this is a division error, input invalid error, or output invalid error. So multiple except you can associate. The one try you can associate except one exception, two exception, three. The multiple error handling block you can associate. So why the multiple exception block? Because I want to give a specific, not the generic message. Maybe here division error happen, can be value error, can be type error. So instead of giving just one error message like error, I want to give, hey, your input is not valid, your key is not valid. So I want to give the specific message as a response to the client. So we have to put the multiple exception handler. This is known as handler 1, handler 2, handler 3, handler 4. So next question, if we have a multiple handler, we have to follow any hierarchy? Yes, we must sure follow the hierarchy. We'll talk whenever I'm going to talk the class where we have to parent and the child relationship. So you can say child would be the first, then parent, then parent, then parent. Okay, so exception handler follow the inherital hierarchy. Okay, we'll talk. Okay, so here might be uh, here you can write maybe, hey, I am going to accept maybe type error as as type type print input is not as expected type. Um, okay, so this is the way here say, hey, uh, number cannot be divided. Number cannot be divided by input 0. Okay, maybe here you can take as an input maybe here let's pass t. Okay, and here pass, let's I pass true. Okay, if you pass 2 divided by t, everything is fine, then the expected output you are getting, right? Okay, so might be if you pass the I pass that's 0. So you are getting the number cannot be divisible. Right? This is the way, at least this function probability, but this code fine, this code fine, this code fine. Other part is working as per expected. Right? So maybe here you pass some like hey, I pass some what happened? If you pass test, so 20 can divided by test? No. So here say hey, the input is not expected type. Here you expected integer, you are passing a string. So here you can say you are getting this. So what if I notice this is the u divided by this? Okay. So this is maybe some different input you can pass or different types of number you can pass. So multiple handler you can pass. Even you can pass some different maybe exception. Okay, itself print other. Okay. So in this way you can handle the multiple situation. So the final the point is that whenever you are writing the particular identify the particular block of code can throw exception, you write inside the try blocks and associate the multiple catch block. Maybe catch block one, whenever particular exception throw, this can go to this handler, or this can be this handler, or this can be this handler. So this is your exception handler 1, exception handler 2, and your exception handler 3. Any number of exception handler you can associate with your try block, so that we are ensuring that our functions are provide the enough clear matches why my applications are failing, or what the input error, or what the other problems. Okay, so you want to give the proper uh, detailed error message to the customer. Okay, so here same like we are divided by 0, and this is the zero division error, or a type error, or exception. Okay, so here if you pass like 10 divided by 2, it is the right scenario, division happen, you are getting the proper result. You are getting a proper result. Might we can say divide by 0, divide by 0, you cannot divide by 0, you are our zero division error handler can handle, right? Maybe you are passing some incorrect value, you can say hey, this is the invalid the input type, invalid the input types. Okay. So this multiple exception handler provide the clear matches to the client. So handling invalid input. Sometime maybe you are writing a program and you are getting from input, hey, write something number. Okay, so you can throw or print say, let us say you have a function like a get age, get get age. Okay? And you are going to just say, hey, I need the age variable. Okay, I take from input. So you say, hey, input type your age, okay, and just you want to print them. Okay, print your age. Okay, comma age. Okay, this is the right. You can call it. Whenever you run this program, this will type age. My age uh, here also right. I type age 22. I am getting it. Okay. Again, I want to let's age. What happened? I type test. Also test. Really, it's a good? No. Your age should be the number. So we are going to ensure that hey, someone must be type the only number. So how to say? We have a going to convert this to test whatever the input you receive to the number. So we know how to convert them. So we know hey, whatever the age you receive. So let's say this is the input age, and this is the convert to the integer and pass your input age. Okay. And here say just say print app is completed. Okay, and if you is 23 done. Let's say I want to run multiple times too. So maybe if something, let's say I run, and again I pass some num, okay, it will fail exception. Okay. So how to handle? So let's write inside the loop. Okay. So you know how to handle it. You know, okay, this is the section where a problem it is. So this section would be inside your try block. Okay, and this is you write your try block or throw exception. Okay, handling exception, and then you can say, hey, try catch. Okay, so you can say, oh, I know, yeah, this is the where conversion happen. You can say try block, and here say, accept. Okay, and here you can say, uh, here if any exception occur, okay, then what you will do. So maybe, so let's just say, okay, so let's say exception, print exception. Okay, as a, okay. So here I'm saying this is the predefined inbuilt exception type, and as is the alias name variable. Right? I'm going to use this as inside the variable. So if I pass something wrong, it's so fine. Again, I instead of run again and again, you can also write the while block. Okay, while block your edges. Okay, let's run it. Okay. Okay, notice you are getting. So here you are now handle exception. Okay, at least your app is run here and pass the some wrong value, and still your application is closed. Something is invalid right now. So here you want to say what happened if let's someone type is 0. So your age is 0 and application, but sometimes this is the now the scenario. I want only the our application get is valid if the age is greater than it. I want to throw. So somehow, sometime your Python interpreter throw exception, like here not a valid value. But sometime you want to throw exception. What happen if you can say if age is less than 18, 18. I want to throw exception. It is not a valid case. So this is the scenario where you are going to use the raise keyword. The raise keyword is the way a programmer can throw some error, maybe value error something. You can say this is the value, whatever the raise raise value error. Okay. So if I can say, hey, now if you run here and you can pass the let's 12, your group is completed. Notice I'm not getting any messages. Even I'm not getting my age. Even I'm not getting the particular, because here you are handle one exception but not handle the value. So you can say, hey, say except value type error as value error. Okay, and print age is age is less than 80. Age is less than 18. Okay, and comma, maybe you can say value whatever. Yeah, or you have option if you not give the proper message, just it is sufficient. Okay, you can also write this. This is not always, if you don't want to, just you want to give custom message, age is less than 18. Okay, are you now you run. So if you type like 5, your age is less than 18. Okay, if uh, hmm, if you again run and you say type age is 45, run, your age is 45. So now we have a option as a business use case. Sometime you want to throw exception, you can also throw. Here what we learn, so we identify this is the section where our application can throw exception. Okay, in this case this is the conversion method in can throw exception. This is the predefined throw, so that we can handle exception. Okay, but sometime I want my business logic, hey, particular is less than, then I don't want to execute the further line of code. I want to say, hey, throw exception. So here you can say keyword raise, and whatever the value error, key error, index error, you can throw, and once you can catch them and give the proper message. So the way we are handling exception right now, that means you decide, hey, this is my business logic, and this business logic can only depend upon this value. Here, if our age is less than, then I'm not going to continue this further code. But if age is greater than 0, then I want to continue the further line of the dependency. You have a dependency. This line of code only executed if this line satisfied some my condition. Right now. Okay. So those scenario you have say apply the we as a programmer also raise exception. A raise exception. So you can use the raise keyword, raise and raise your exception. If your condition is true, your business logic is work as per expected. So this is the scenario where you can handle your input invalid input. You are handling invalid input here, and even you can throw your custom exception. Okay, and finally you can test this way. Okay. Similarly, might be your function is kind of this. You are defining this function, and this function is something divided by 0. Everything okay? Then you can also throw some. You want to have some error message here, some division exception or something. Then you can also do. That means one function can throw exception, and you can also handle them. That means let us. You have a define division div1 function, that one take x comma y input. Okay, and you say try just say z equal to x divided by y, print z. Okay, except that's zero exception, and here I don't want to, but here is if you say print, okay, divide by 0. Okay, this is the way, and here say division 1, say 20 divided by 2, or you can say division, say maybe 30 divided by 0. Okay, if you run, you are getting this, you are getting this. Okay, but I want to this division function handle the exception. I don't, maybe here something happen. Again I call with a 5. Okay, so notice here our program is this. I don't want if this division function I call, I am not getting proper notification, something unwanted happen or not. So this function I want to get the output, something they return the exception message. So instead of here handling, here means here we can handle exception, we can suppress the exception, but I want to propagate. So instead of say, hey, I can say no, I can raise the exception here. You can see here I'm going to raise maybe different runtime exception or runtime error, runtime error. Okay, division are not allowed. Division are divisions are not allowed. Okay. And if you run this method now throw exception, that means you have to handle in the here say this code should be say try block and accept exception and print message. A message you can take as a comma A. So now you have defined this function. This function is working fine or maybe throwing exception. Once through exception, you have to handle this. And then again try catch and whatever the message you want. Okay, okay. This. Yeah. So now message not allowed. So here you can, that means what here we are explaining. So you have defined this function. This is the function. This function can print output or throw exception. So here, if you are calling this function that are throwing exception, again you have to mention try catch and handle the exception. Okay, so this is the way you can one part of application throwing exception, another part you are handling, another part throwing exception, another you handle. So here programmer can handle the exception, but not, but again throwing exception. As someone call this function, here someone call this function, again handle the exception and give the proper message. Okay, so this is known as a exceptional chain. Okay, so you are propagating exception from one place to another place. That means, let's say this is the f1 function, you calling, okay, you calling f2 function, you calling f3 function, you calling. So if this will throw exception go here, if throw exception go here, if throw exception go here, and who call them, that responsible to handle the exception. So the way you invoking function, so here I call this division. If division throw exception, come here and I handle. So if maybe I can also rethrow them. So this is known as a function chaining. So any exception are going to back from where the call. That means if this is f1 function, call to f2 function, and call 3 f3 function, call to f4 function. If this function somehow throw exception, so go back here. If throw they can handle exception, or again throw it. Can handle exception, again throw it. Okay, so if say hey, those scenario they exception throw exception, they throw, but I say no, I can't throw, I can handle exception. So here they can handle exception, and next line of code going to is here again not going to the back. So functions invocation happen in a channel. Okay, function 1 call 2, 2 call 3, 3 call 4. 4 have any exception, again back to the 3. 3 have any exception, back to the 2. 2 have, back to the 1. So your exception are going to chain back to the back to the back until someone is not going to handle. Until someone raise exception means you are going to the back, you are going to the back, you are going to the back. Okay, so for raising exception, we have to use the keyword raise. That means now the raise keyword given option to the engineer, to the software developer, can raise exception. Hey, here exception, or runtime exception, or value error, key error, and give your message, whatever the message you want to give. So you can throw exception. Like here, we are throwing exception with this keyword, and what are the message you want, right? So this is the one option. Whenever you have a one try block, this is the one try block, okay, and multiple exception handler 1, exception handler 2, exception handler 3, okay, in this. So this scenario, if any exception handle, any exception occur, then any one of them then can be caught. First ensure that this is child, this is super child, this is a parent. So always be, if this exception not handled, then go to the next case. If not handled, then go to the next case. So please be ensured that this handler block follow the hierarchy. So your super exception type always with the throw, so that if you write this one in the first, so always everything handled by the first, this is never executed, never executed. Are you getting my point? So always try to exception handler in the hierarchical order. Child to child to child, then parent, right? But what happen if all is okay, but you want to give some final works always? So for those scenario, this is option is finally. The finally try have a catch or finally. Catch means your accept and the finally. So any exception in the block happen or not, this finally is the always executed. So sometimes some situation where happen your try block, if throw exception, that means your catch handler can work. If not through exception, everything is okay, then the control goes to the finally always. This code is always executed by the Python compiler, even exception occur or not occur in both cases. That means if you are particular code associated in a try block and you want always be this line of code should be executed, maybe exception occur or maybe exception not occur. In both case, this line of code executed. The finally block associated with the try and can be executed always, even the exception occur or not occur. So let us example. Okay. Define function. Okay. And try block. Let's set equal to 4 divided by 2. Print set exception 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 as okay, and then your finally print finally execute it. Okay, maybe multiple catch you can write it, maybe 0 error. Okay, so here these are possible. Your try block can associate your exception 1, exception 2 are finally blocks. Okay, and let's F1. So whenever I run, notice finally block executed, even there is a no exception. So let's input. Let's y. Y, okay, and here let's pass 2. F1, let's pass 0. So notice these are finally executed here, divide by 0, then finally executed. That means even the particular try block, this block are the conditional. This code is executed only if the particular if this block throw any error. If any error occur, yeah, this executed or this executed. But this after once this is executed, this finally block is the always executed in the both cases. The sometime you want give the some final cleanup message or some either database file opening or closing you want. Always you want to the set of code must be executed once this block of code is done. So in this scenario, you are going to use the finally block. The finally allow are given an option where the line of code must be executed after the completion of try block. Let's say you are opening the file, the database connection. Once database connection is done, success or failure, doesn't matter, or any particular file opening, you are open the file doing something and then you want to clean up the close the file, close the database connection. In those scenarios, finally block help us. Okay? And these are the sometime notice here we are writing this zero exception type. So this is known as a inbuilt Python provided this classes to you. Is it possible I can say here uh, my exception handler or my business error, my business error, something. So if sometime you want to your own class, then you have an option to the custom error. So you can write here, hey, so let us say, hey, you can just define your own class, okay? Okay, so here say class this, and you can pass exception, and I just I'm just pass the business, okay, right? Okay, so in this way, so notice now here our compiler is okay. So here you run it's okay. So sometime you want your custom user defined exception type, then you can just write your class and inherit from exception class, or maybe here zero division by exception from here, and you can get the value. So here instead of you are writing the specific here, let's give on to for maybe my here you can say my business division zero. Okay, this is things right now. So here right you can right. So someone read the code here. This is my business division zero. Or you want to my exception. Similarly, you can say, hey, this is the my exception. Just here inherit from here, and here say okay, here, and here you can say here. So here you can write your inbuilt or Python inbuilt or your own. It's working for both scenarios. Right? What is happening? Something. No. Alignment is okay. Okay, in this print here e this my exception and print What's a most recent call? What happened? Okay. So now here, finally, they are throwing exception, then you have to handle as well, right? So here, my exceptions are not handled though. Okay. So due to that, you have to maybe write some most exception base exception as e. Okay. And if you write here 0. Okay. So somehow ensure you have to hierarchical. Someone must be handled. Okay. So this is the child, two super, two super. What the hierarchy also? How this hierarchy follow? So whenever one try, multiple exception handler, and one finally block. So this is a possible scenario. So you can say uh, the try and finally also works. Okay. Or you can say try with the exception handler, exception, or try with multiple exception, or try block with multiple exception, and even the finally block. So maybe try with finally, try with exception, try with multiple exception, try with multiple exception with finally. So all the permutation combinations are works. So whenever you have a multiple exception handler, ensure that this is the super parent, then the child, then the child. So look like child means the small block capacity. Here is the bigger capacity, and this is the bigger capacity. Okay. Okay. So you cannot like a reverse, like here super class, then subclass, then subclass. This hierarchy is not allowed. This hierarchy is allowed. So always the child, then the parent, then the parent. So here, here, here. Okay. So this is known as a custom exception. That means you can create your own custom exception. Just your class, the name, and whatever the exception you want, and just even you can throw this exception, rows, raise this exception, raise this exception. Okay. So even you can say here maybe. So here you can say like this way. Let's I say 0. Okay. And here I can say hey, raise my business exception. Okay, it's also work, and someone call them, you are getting exception. Okay, raise, hey, this is the my business exception are thrown. Yes. So someone can go and handle them. So this is the exception throw here. Here you can throw. So here you can send it. Okay, try this except exception e print. Let's e run it. So in this way, you can handle the exception. So a custom exception can be handled here or can be throw. You can just throw your exception name. So you can throw and someone again catch them, custom exception. Okay, even someone can catch the exception. Here you can say, even I can say, here you can say here, hey, I want to my business exception. So here it works. Okay, right? So even here you can catch your exception, or even you can throw your custom exception. You can write your custom exception and use the place where you want. So generally, whenever you are writing applications, and generally depend upon your domains, you can write your custom exception for the business domain. So as we maybe discuss chaining, this can throw exception, again you can raise exception, and again you can throw exception. In this way, you can perform the multiple chaining. So these are the some common error handling scenario where you have to whatever the discuss maybe whenever you are working on the file input output. Till now we will not cover, but we are going to cover. So whenever you're opening the particular file, may file not exist, or file a permission issue, a permission denied issue, or some IO exception. So this scenario, you must have to handle your exception. Maybe you are working some network. Maybe you are going to the connection with the remote server, database server, maybe timeout issue, or network related issue. You have to handle network error as well as. Maybe you are connecting your application connected to database, or maybe database connection issue, a connection timeout, a query error, or database any related exception throw. You can handle the database error, or your applications are accessing user input. So maybe user types some name, number, phone number. So might be some user can type incorrect data. So in those scenario also you have to handle the exception or error. So the depend upon the nature of your applications, you are working with a file system, network system, database, or user input. Accordingly, you have to use this try catch or exception handling mechanism. So this is a very simple rule. Whenever you are going to use this try catch blocks, as a engineer, we have to follow some best practices. So something handle the specific error. What do you mean by that? Whenever you are writing the try block, and try block code can throw exception, and you have handle exception 1, exception 2, exception 3. Why? It depend upon your exception, you have a specific error instead of just not just general exception. So avoid the catching general exception. Instead, you catch a specific value error, type error, divide by zero error, arithmetic exception, index error exception. So that whenever you are throwing masses, so that the developer or client can exactly understand, hey, this is the actual problem. You can return the actual problems, and keep try except block sorter. That means keep the try block inside as a sort as possible. Don't write to your try block is the lots of code, and as bigger code as possible to generate high number different types of exception, and then you have to going to handle different exception. So the basis business same logic is that your function edge is small. Similarly, your try block should edge is small, and some log exceptions, or maybe a dip for debugging purpose for exception, finding out some issue. And whenever you're testing your application, you can handle your application, or even the except whenever you're doing exception chaining, be carefully, because whenever you are calling function 1, 2 function 2, 2 function 3, be carefully propagate chaining back to the call function. Okay. So these are the some points you have to keep, and if you want to understand the more detail about this error or exception, and what are the inbuilt custom type, so these are the documents you can refer. Okay. Okay, so these are the documents. So here, whatever the I show you, it's everything in the Python official library, and what are the syntax error, what are the exception right now. Everything maybe you are writing some incorrect writing a line. This is the invalid syntax error. What are the exception? Maybe divide by zero exception, or multiply with the different power of the number. These are the different. How to handling exception? Hey, try block, whatever the input you have, and then your accept block, that is exception handler. So all the definition, try catch, everything mentioned here. Even you can write your own custom exception B, C, D in this way. You can try and raise exception class and B, C, D, and follow the complete hierarchy. The raise keyword are used to raise the exception we discuss. Whenever you're working with a file, open file, read line, always try to handle the exception, right? Everything more details are here. You can just go out, and this is the where we can found all the inbuilt exception and hierarchy. Okay, go to the little bit down. You can read out everything, but here all are the this. So this is the your notice the base exception, and base exception have a base group exception, generating keyboard, system error are exception. If you are kind of this, so this is the first, maybe you are dividing by 0. If you handle this or this the relationship. So let us, okay, so here you say divide by 0. That means this is the you are handling. And let's arithmetic error. So here say, just for just just remove it. Just remove it. Okay. Okay. So here say accept arithmetic print. Okay. Okay. Yeah. So that's good. And you can say here as you want to give the message, comma. Okay. It's fine. So if you handle this arithmetic exception, okay, so you handle this arithmetic, then this is the exception is the super class and this is the child class. So if let's you handle, now we're going to handle divide by 0. So what happened? So here say, and let's you say I am going to divide by 0. Okay. So notice here, they are not happy, right? Because this divide by 0 is already handled by your parent class. If parent is already handled, this code become unreachable code. So these are not allowed. So that means this always should be, child should be first. In this way, it's better. Okay. Similarly, this is the exception. So you cannot handle exception on the top. Let's here say, and here you can say exception. So once say exception, that means all the exception are handled. These are become your unreachable code. This is not the top. This should be on the down. Okay. So please note, this is the hierarchy we have to follow. So this is the child, this is the parent of that, this is the parent of that. So these are the hierarchy mentioned here. If you are handling this first, then you can handle this, then you can handle this, then you can handle this. So these are the hierarchy you have to ensure, and all the possible Python built-in exception already error handle. You can exception arithmetic error, or similarly you can go like memory error or a file error. Here you can go. This is the file not exist, file not found, interpret. So here you can get OS error contain all this. Or similarly your runtime error, or similarly your value error or type error or system error. So all these are the inbuilt class hierarchy available. So whenever you are writing try and multiple catch, so please ensure that you follow this hierarchy. This is the parent, this is the child, again this is the child, again this picture. That means this is the child, his parent this, his parent this, his parent this. So whenever you're going to write the multiple exception, then child first, then his parent, then his parent, then his parent. So this is the hierarchy please you have to maintain. And these are the basics kind of existing, you can say inbuilt, predefined, all are the exception hierarchy. So we should aware. And apart from that, you want to own your custom, you can use the custom as well as. So that is for the related to the your error handling. And this is a very you can say important for the any programmer. Okay, so whatever the code you writing, okay, and your code, look, they take input from outside, maybe from the customer, from input, or you are reading file from somewhere, getting data output from here, and you are doing processing something on those input. So might be this code can generate exception. So write those code inside your try block. A try block with your exception handler except. Or try block, your try block with a multiple exception handler. Multiple exception handler. Here your child first, then his parent, then his parent. Only child, his parent. Followed. Maybe try block with a finally block as well as this. The try finally always executed. Maybe try block and try block and multiple exception, multiple exception, and finally block. So all are the permutation combination. Your try with exception, try with multiple exception handler, try with finally, try with multiple exception, and the finally. The finally block always executed. Okay, so whenever you are writing any function, and please be careful. If your function is very internally, they are not depend on any outside the output or input, then your function not require the try catch exception handling. But your line of code, any codes are depend upon the user input, the user can pass the wrong value. So you have to handle it right. Or you are opening a file on the operating system, maybe particular file exists, not exists, permission issue, you can handle it right. Or maybe you are accessing database. Okay, so database handling might be database shutdown, a network issue, a connection issue. Your function must be handled try catch. So whenever you are writing any function that are depend upon the user input, that's a depend upon the file system, that's a depend upon the remote server, you must handle try catch so that your application can behave as the way you want, not the they are going to terminate it without any kind of a warning message, right? And you should aware all the built-in Python exception hierarchy. And whenever you are writing the multiple exception, you have to follow the hierarchy properly. And these are the basics about the error and exception handling in the Python. And you just explore them, you do them, you write some code and do practice. Okay, this will help you little bit idea how the exception handling you can implement in your program. So that's for the day. Thank you.